Hello, my dear children. I am going to teach you today. So, how to find the equivalent resistance of a cube, which is having equal resistances. It is given like that. So, this is the scenario. So, we can solve the resistor cube problem. Say for all the resistance should be it is equal to the 1 ohm. Okay. For example. So, I will explain you in a proper way that how we can find this equivalent resistance or effective resistance by traditional method. I will explain you about the traditional method right now. So, this is the usual method, and then we can able to group this. See how I will explain you about all these things. We are just determining this diagonal. So this H, it stands for, you can name it like, so this one and this one and this one. These three resistors are connected by this way, and then we are going to name it like this will be A, for example, this resistor, this will be B, and this will be C. Like that we are going to see. So A, B, C are the resistors. Okay, so and then now I am going to mark other one. So these A, B, C are now connected in series here. So this is what I am going to explain. So this 3R. Okay. This is A, B and C. Let this be first one. Okay. So we are going to fix this network, and the next network be, what is the next network? Like, so we are going to fix this 6 resistances. Okay. So what are the 6 resistances? This is 1 and 2, this junction. Okay. And then 3. Okay. And then this has 4, and then so here these 2. Okay, so there are 6 resistances which is connected like this, parallel, parallel, parallel. So all are parallel. These are all the 6 resistors. Understood? Okay, and then again we are now going to see these 3 resistances. You know that these 3 resistances, this one, and this one, you can join like this, right? You can join like this. Sorry, this can be done like this. You can join. Okay, these 3 can be joined at the back side. Okay, the front face. This is the front face, this is the side face, lateral face. So these 3 combine, and then this forms a 3 parallel resistors. Okay, so how come you just find the equivalent resistor of these 3 things? What is this? First we will solve for the first one. What is this first one? 1 plus 1 plus. What is this first one? It is actually at A. Okay. So what is the effective resistances? You can come to know. The effective resistance is parallel, right? The parallel resistance can be 1 by A plus 1 by B plus 1 by C. So that is equal to 1 by 1 plus 1 by 1 plus 1 by 1. So that is equal to, what is this? 3 by 1. Or this is 1 by R effective. So if you want to find R effective, so what is this? 1 by 3. So 1 by 3 times R we can say. If it is R resistance, it is 1 by 3 times R. What about this one? So it is 1 by 6 R times. Likewise, we can calculate. This is 1 by 6 R. And then what about this one? This is 1 by 3 R. The same like here 1 by 3 R. So these can be connected in series here. Okay. So this is now connected in series. In series means you can able to add. So from A, so this one is, what is the equivalent resistance of this particular thing? That is 1 by 3 R. Okay. What is the equivalent resistance of this particular thing? This is 1 by 6 R. What is the other one? That is 1 by 3 R. So you need to add 1 by 3 R plus 1 by 6 R plus 1 by 3 R. So what is the resultant now? So you can take LCM 6. So here it will be 2 plus 2 plus 1. So 5 by 6 R. So that is the equivalent resistance. So it's a famous method, traditional method to find the equivalent resistance. We can make use of current law and voltage law to find this equivalent resistance also. That is Kirchhoff's laws we can see. So if you want to take a screenshot, you can take a screenshot, then we will see the next. Okay. So we will see this next one. So next one is current method. You know that the junction, right? At the junction, the current flowing inside and the current flowing outside. This can be taken as algebraic sum. The current flowing inside will be negative, the current flowing outside will be positive. So that the algebraic sum of all the currents within the circuit, at the junction is 0. So based on that, we can take all these things. You can check with this, you know all these things, right? So this is one method. And again, we can done with resistance and the potential method also. So first, traditional method is very easy when compared to normal, current method and potential method. Okay. So all are based on what? The potential difference. The potential method means we can say the potential difference here. Okay. So this is potential method, the potential difference. But whatever it might be, it based on all Ohm's law. Okay. So current, voltage and resistance are connected. If you want to find the equivalent resistance, my advice is you need to find through normal traditional method. So that is very easy, and then this is the way you need to draw equivalent circuit. Is it clear for you? This is an equivalent circuit. You need to draw for a cube. Same way, if you are given capacitor, you have to draw like this, and the capacitors in parallel should be like this, right? This is the capacitor in parallel. You know that the capacitor in parallel should contain what? You have to add directly the parallel capacitance, right? So what is the equivalent capacitance in parallel? Effective capacitance in parallel? You can simply add. So this will be C1, C2 and C3. You can add C1 plus C2 plus C3. So that is equal to 3 times R. Sorry, 3 times C. Okay. So this will be 3 times C. Like that you need to follow. Okay. So for capacitance, the parallel should be similar to the series and resistor. So that means you have to directly add all the capacitances. Okay. So equivalent capacitance. So C1 is equal to C, C2 is equal to C and C3 also C. So if these three are equal, then that is equal to 3C. Right. Okay. If the capacitance in this place will be, what is in this place? 6C. So 3C, 6C and then 3C again. But these capacitance, these equivalent capacitance, first equivalent capacitance, here it should be 3C, second equivalent capacitance here it will be 6C, third equivalent capacitance here it will be 3C. See, for example, this will be G and A. How these are connected now? These are connected in series. For series, what is the effective capacitance we can do? Based on the formula, this is. So this tips you must understand. Okay. in order to just draw an equivalent circuit for the given Q, you have to follow this step. This is the traditional method. This step is very important. And then what about the effective resistance, effective capacitance in series? This will be 1 by 3C plus 1 by 6C plus 1 by 3C. So like a way you need to find what is the resultant here. So 5 by 6C, right? 5 by 6C it will be. Okay. So in this, what is the effective series? So that's it. That should be 6 by 5 into C. So this is the way you have to interpret with both what? Resistor as well as capacitance. This is very simple. You can able to understand. So let me give you some explanation regarding with this equivalent resistance. So how we can draw the equivalent circuit from the given one, from the given trivia kind of circuits. Okay, so we will see such a network right now.